Please hang up and try again.
Hi, everybody. Welcome to another session. Today, we're going to talk about arrays. Array is another way to basically store information. I know for many weeks now, we store information in variables with different data types, with different capacity, and maybe for different primitive types. So today, we're going to talk about how arrays can help to basically store that information. We're going to talk about definition, initialization, and a couple of the operations that we can do with arrays. So first of all, what is considered to be an array? So arrays are, as I mentioned, are used to store values very similar to variables, but the only difference is that they store contiguously. So they compact everything, all the information that you need contiguously in a data set in memory. So instead of just declaring, I don't know, like 13 or 14 or 25,000 variables, we can just simply create an array and store all that information there in an array. You can visualize this as like in a bag or basically a storage when you can store them everything contiguously. The way we store this information into the array is by indices. So we're gonna have a zero-based indices, means that we're gonna start at position 0 and we're gonna go all the way to the a.length minus 1. We have seen something similar to this when we talk about strings. I'm gonna talk about that in detail and how arrays work in relation or similar to a string. In Java, arrays are objects. I know some of you are still debating what is this object, although we have been working with objects for the past weeks or the previous sessions. The notion of objects is a little bit obscure, a little bit mysterious, but we're going to talk about that in the next lesson. Every time you create a new array, we need to use some kind of mechanism, a keyword in particular called the new, as you can see here. So let us start by describing what exactly we need when we store some variables. As you can know, suppose that we declare here a couple of variables, maybe x1, x2, x3, x4, and x5 with different integers values. This is how we've been storing information for the past weeks. And everything is fine, everything is normal, everything is great. The problem is that when we start to introduce more variables, it's a little bit difficult to handle. What we need to do here is to visualize a box. Suppose that we have a box like the one that you can see right here that stores 5 values. Now, this representation that you can see here is typically the array representation that in computer science we use in order to visualize an array. Notice that we start at index 0 and we go all the way to the size, which is 5 minus 1. So the first value will be at position 0, the second value will be at position 1. Value from the variable x5 will be stored at position 4. So basically, when you see this kind of values, we always count at value 0. This is very similar to what we have discussed with strings. We play the same pattern here. So every time we see these values, we can accommodate those values accordingly to these positions from this array. The question here is how we're gonna declare this part. And this is the way we're gonna store. We're gonna create an array of integers that hold 5 values. Let us inspect more in detail this formula you can see here. Probably for you it's kind of sorcery, so let's try to visualize what is happening. The very first thing that you see here highlighted is what we call the data type. These data types, they must match, both of them. So if you have an int square bracket in the left hand side, you need to have the int square bracket in the right hand side. So those data types must match. This is the way you tell Java to tell you, hey, can you please store this box in memory that is going to hold 5 values for me. By the way, they're going to be integers, so make sure you allocate the precise capacity that you need for that data type. The next part is an indicator to tell you, hey, we're dealing arrays. So every time you see those square brackets, that means that we're dealing with arrays. You probably remember this, guys, when you saw something called public static void main, and then open those parentheses, string, square brackets, args. Believe it or not, we were dealing with an array of strings at this point. By the way, the main is a main method that will take an array of string as an argument. And we're going to talk about that in more in detail later on. But I just thought, since this is the very first time you deal with arrays, that you need to make that connection. This part is an identifier. We call it an ID, but basically you can call it whatever you want. I call it A for array. Just remember, I'm lazy, so I just want to put A for array. The equals new, it's how you create a new object, a new instance of the array in Java. Nothing new here. Remember how we create a new scanner, or when you create a new file or a print writer, something like that. This is the way we basically create a new instance. Okay, a new object. Okay, in Java, this is the way we define it, we create a new instance. And we're going to talk about more in detail later on when we deal with objects. And the value inside of those square brackets after the equal sign is the capacity. Here is when you specify to Java that you need to have a box, a storage, an array holding 5 values. So this is the general formula to create any type of array with any data type. How are we going to store information? So you can see here in the very first line how we define or how do we declare an array. And the next 5 statements is how we actually assign or store the values in those particular values in the array. Notice that we start at position 0 all the way to 4. Those are the 5 values that we want to store. Array at position 0 contains the value 5. Array at index 1 contains the value 3. Array at index value 2 contains the value of 2. Array at index 3 contains the value 24. Array at index 4 contains the value 7. Now, there's a shortcut. In case you know the values that you want to store, you can use the shortcut as you can see right here. The only thing you have to do is to declare the data type, array, int, square brackets, a equals, and then you open those curly brackets. You separate by comma each value that you find there. For example, here I have 5, 3, 2, 24, 7, and that's the way you're gonna create a array containing those values as a shortcut. You don't have to have those 5 different lines of code there. So the way you access the data from the array, there's probably 2 ways that Java can provide for you. One is by printing the location, and one is by printing the element and the indices. So here in your right hand side, there's an image that basically describes one of the outputs that we're going to talk about. It's called the hexadecimal address location. So that is the location of the array. I just want to mention that real quick so you can have an idea what is that about. You can use the base 0 to basically access all the information from the arrays. And one of the helpers, one of the best friends forever, are the loops. So loops can help us to basically navigate through the entire array and access that information. Remember, the array counts very similar to a string, counts with the attribute called the length. The length helps us to extract how many values you have in this particular array, and it can help us to construct those loops. So consider the following array. One natural way to print the values is to use the system out print line and then print the array A in this case. So you might think that you're gonna get all those values printed, but instead we have this. So this part that you see here, it's a funky value indeed. So let us go ahead and explore what this really means. This is what we call the hexadecimal hash code representation, or also known as the toString. I know there's a lot of technicality here in the words, but we're going to talk about the toString soon. We're going to talk about the toString primarily when we deal with objects. And this value, I know it's a lot of weird symbols there in numbers and letters, but this is the way Java recognizes the location in memory where the array is being stored. This is the meaningful part from the computer to the computer. As a human, for us, it's a little bit weird to see this, but let us inspect what this really means. This part is considered to be an array. That is the square bracket representation that Java will indicate that you're dealing with an array. This part is we're dealing with integers. So if we're dealing with an array of doubles, instead of an I will be a D and so on. This is the at sign, which pretty much tells you that the array of integers is located at, and then we're going to provide the hexadecimal address location. Now, hexa means 16, base 16. So basically, in case you want to represent your digits from 0 to 16, you need to use hexadecimal for 1 byte. In other words, from 0 to 9, everything is fine because that's 1 digit. But in order to represent the number 10, you need to use A, 11, B, 12, C, 13, D, 14, E, 15, F. Where is 16? Well, remember, because we start at 0, that is the way we represent the 16 bits. But if we want to store something more humanly speaking, we just need to print those values using the system out print line, like the way we just did here. So this will generate some output like the following. I know what you're thinking. Can we just make this in a simpler way? We're just printing those 5 values using the system out print line, Professor. There's another way to do this. And of course, we can use the loop. Remember that the loops are the best friends forever from the arrays. So let's construct this loop based on this information. So you can see here that we're going to start at position 0. This is a 0-base array. So that's where we declare a variable called int I equals to 0. As long as I is less than 5, because we have 5 values, we're going to go one by one, I++. In the meanwhile, you can see here that there's a lot of repetition with the system out print line. So that will be part of the loop. And instead of just printing A at position 0, 1, 2, 3, and 4, we can just print A at position I. Remember, the I is the control variable that will control the numbers between 0 and 5. Let's trace it. We're going to start in the left-hand side with the loop. And the right-hand side, you can see the tracing of the variable I. We're going to do it step by step so you can recognize both the execution of the for loop and how can we access those values from the array. So we start at I at position 0. And then we're going to compare if the value here 0 is less than 5, which is indeed true. Because it's true, we're going to go to the body of the loop and we're going to print system out print line array at position I is 0, so that will give us the value of 5. After the execution of the body of the loop, we're going to go to the update. That means I++. So now we're going to increment I by 1. Now it's going to be 1. We're going to go back to the check, and we're going to see if 1 is less than 5, which is indeed true. Therefore, we're going to go to the body of the loop and print system out print line, and then we're going to go array at position 1, which happens to be the value of 3. After that, we go to the update, I++. Now the value of I will be 2. Next, we're going to go back to the comparisons, and we're going to do, is 2 less than 5? That is true. Because it's true, we're going to go to the body, system out print line array at position 2, which is 2. So we're going to print the value of 2. We update I++. Now the value is 3. And we're going to go to the check. and ask, is 3 less than 5? Which is indeed true. So we welcome to go to the body of the loop, system of println, array at position 3, which is the value of 24. We're going to update the value of I by one more by using I++. Now is 4. We're going to go and check if 4 is less than 5, which is indeed true. So we're welcome to go to the body of the loop, and we're going to do the system of println array at position 4, which is the value of 7. By using I++, we're going to update the value of I, which is now going to be the value of 5. I want you to pay attention because after the update, we're going to go back to the check. But when we come back here to the check, we're going to see if 5 is less than 5. And in this case, is not true, therefore false. Because it's false, that will terminate the execution of this loop and we're going to exit. And this is the output that we're going to generate after this execution. How can we simplify this output or this processing? We have dot length. It's an attribute that is being provided to the array. So instead of just put there any other value, we can simply just put a.length and that would automatically do the same output. And the only thing we're doing is navigating from 0 all the way to 5 without including the 5. Let's go ahead and write a couple demos to explain and illustrate the topics that we just covered. Let us demonstrate how to create an array by using the steps that we covered before. So the very first thing is to create this formula that we mentioned previously that will basically stores the data type that you want to store, the identifier, and then this equals new to create a new instance of the array. Remember that the data type here must match with the very first part that we discussed here in the very first part of the entire definition. Inside of those square brackets is when you put the capacity that you want to have in this array. The next thing is to populate, which means that you're going to specify the array at position 0 will contain the following values. What we just did is that we populate the array from position 0 all the way to position 4 with the values that were given us initially. Notice that we start at position 0 and we go all the way to array position 4. We don't store the value 5 inside of the square brackets because that will give us an array index out of bounds. The next thing is to print them. So if we store the values in the array at position, all those indices, probably will be natural to just print the value of A as the array. But I just want you to see what's happening in this particular example. By compiling this program and running this program, we got this hexadecimal address location that we already talked about. So this is where data array is being stored in the memory based on the Java formulation. So how can we print these values? Well, one way to do it is by basically specifying each index. As we did here. By specifying each index, that will actually ask Java to go to that particular index and print those values, as we can see here. I'm going to create another example so you can see how can we reduce this part. Let's just create another variation of our array example 01. But instead of just having this declaration, I'm going to use this shortcut. Since we already know these values, it's probably easier to have just store them into the curly brackets. For example, we can just say that our array will contain the value of 5 and 3 and 2 and 24 and 7. And we don't have to do all line by line. The only thing we have to do is to accommodate it into the very first line. Remember that this is called the shortcut and only is helpful when you know the values beforehand. There's a trade-off. Once we create the array, like in our previous example, once we establish this value there, we're going to stop with that for the rest of the program's life. Sometimes we will have to reaccommodate or expand in that memory later on, and that's going to be a hassle later on. But let's for now not worry too much. But this value is very important because that's the way you're going to store that information in memory. In our shortcut, since we already know these values, we can just put it easily enclosed in that curly bracket. Let's save, compile, and run this program. As you can see, we got the same result. Let's make another variation of array example 02, but this time let's reduce the statements. There's a lot of repetition here, and that's unacceptable. I mean, this is kind of cute when you have 5, but what happens, for example, if these values get expanded? For example, suppose that we have more random values here. Suppose that we have more values. What are you going to do? Are you going to do this? I think we have 29 values here. And what we're going to do is that we're going to print from array position 0 all the way to 28 because that's the last value that we can try to access. Let's save, compile, and run, and let's see what happened. I mean, we were able to print those 29 values, I believe. Yep, we were able to do it without any problem. Now, the only problem is that if you show this piece of code to your boss, they're going to tell you you're super fired. This is not good. Where you took these classes of programming, this is ridiculous. Let's not get super fired and let's try to make this nicer. How can you print all those values that we're just providing without doing this system out print line? Obviously, a loop is the solution because look how many repetitions we have of the same statement. So once we identify the statement that we want to repeat, we only need one of those statements, and we need the for loop that goes like this. We're going to start at position 0 because it's a 0 base. We're going to go as long as I is less than a.length. A.length is the key part here. A.length will go here to the array A and tell you, hey, tell me how many values you're holding. This guy is going to tell you 29. Okay, so this will be treated as a 29. And it makes sense because relational operators are Boolean relational operators, which means that you're going to compare an int versus an int, and the result should be true or false. So here, the only thing we're going to do in the meanwhile, we're going to put it inside of the body of the loop, and instead of putting just the value of 0 or 1 or 2 or 3, we just put in the value of I, which is the control variable. Let's save, compile, and run this program. There you are. Basically getting the same result without using 30 lines of code for whatever reason. This is elegant, this is nice, and help us to go, and you can put more values if you want. You can put our thousands, maybe 1 million of values here, good luck. And with this piece of code that you have here from line 5 to line 7, this is a very powerful piece of code that will help us to print all the values. It doesn't matter if there are 3 values or 5 million or 2000, it will be printing all the values from that array. Another thing that we need to recognize are strings and arrays. They're very similar. As a matter of fact, strings are an array of characters. I don't know if you noticed, but every time we access information from a string, basically we are accessing the char at, the character at position. So this is another way you can declare a string by creating a char square bracket string equals, and then you just provide character by character the elements. It's a little bit complicated and long and a little bit lengthy. So that's why we recommend to use just the object of strings. But in reality, what the string is doing is declared an array of characters. Remember, the strings use methods. In arrays, we use immutable operations, means that you cannot change those operations. Operations like dot length, that's a method that you can have in a string, but we can use this immutable operation called length without the parentheses in array. We also can use the method of dot char at position I in a string versus what we can use in an array and then square bracket I to access that information. Again, loops can help to access this information. Something that you need to be aware is to watch your bounds, which means that an array in Java provides values from 0 all the way to a.length minus 1 inclusively. Remember that everything that you can access falls in that interval, in that range. So if you try to attempt to access data that is probably negative or greater than that current array's capacity, it will result in having an array index out of bounds exception. An array index out of bounds is when you're trying to access values that are not in that interval, in that range from 0 to 4 in this particular example that we've been working with. For example, suppose that we want to access negative values in the array. So this will give you something called java.lang array index out of bounds index minus 1 or other negative value is out of the bounds from the length of 5. This is to specify that there's only indices from 0 to 4 to access the value from this array. In similar fashion, when you're trying to access values that are positive, to are beyond the 4, notice that 5 is there, and that's a common mistake because you know you have 5 values. You're trying to access index 5, and that will give you index out of bounds, an array index out of bounds. This is when we're trying to access the array index 5. So every time you're dealing with arrays, make sure you're dealing with the boundaries that you need. Let's write a couple examples to demonstrate this previous topic. Let's compare strings and arrays just to make sure you understand the difference. We can create character array A that will contain the values of a character array, which is also known as a string. We're creating here an array of type characters. Let us try to print the value of A. I know we have a hexadecimal address location explanation for that particular item, but I want you to pay attention on the following cool trick. Java C, array example of 4.java, Java array example of 4, there. Hello. Why are we getting hello? In the other example, we got that funky variable called hexadecimal address location. Remember that strings are an array of characters. So Java recognizes this array of characters as a string. As a matter of fact, we create a string, for example, S, and we put the value of hello, Java will recognize it like that. So this is the array, and we're going to print the value of S after that. And you cannot see the difference. If you can see here, after we compile it and we run it, both are hellos. I hit an extra enters there. I apologize. There. Java recognizes that as part of an array. Now, let's try to process those values step by step. We can use the for loop that we have already in mind, and we can do the system of parent line, array at position I, so you can see what is printing. This is the printing the characters of the array. We can do something similar with the characters of the string. So we're gonna put here s.length. Make sure you put parentheses to make sure you're dealing with the method, and do s.char at position I. So I want you to contrast that one is the actual array, the other one is the actual string. Let's compile and run this program and let's see what happens. No difference. Can you see that? Can we check if both are equals? Can we do system operand line? Can we consider are they equal? And we can use as that equals, and then we can put here the array. Let's see what happens. False. This is where the interesting thing comes. One of them, remember that the dot equals is a method that we obtain from the object. So we used to compare strings this way, dot equals or dot equals ignore case. Maybe that compared to. But here, Java is providing us false. Why is this false? Well, one of them is a string and the other one is a char. So they're not the same. Java uses internally in the object string to transform your array of characters. So you can read something similar to what you can read with the string, but they're two different things. As a matter of fact, they're two different locations. How can we know? We can print them the hash code. Let's compile and run this program and compare what's happening in memory. I want you to pay attention on the string hash code 99162322. That is the memory location where the string is being stored. The array hash code is a different one, 6688494042. There are different locations, but they're also different in equals values in content. Location wise and content wise, they're not the same. Although they read the same at the very beginning when we were printing the hello and character by character hello, there is a difference in location and content. So be careful with that every time you deal with strings and array of characters. This example, we're going to use the same value that we were using at the very beginning of the examples. We're going to create an array with 5 values. And let me demonstrate how this can be tragically gives you an array index out of bounds by using the regular for loop. This is a typical error that we got. Some people might put here 5 as instead of a.len, we can put here 5, and we try to say the system operand line array at position I in order to basically print those values. Some of you would like to store the value 5 there, which means that you want to include the value 5. Be careful, because when we're trying to do this, let me just compile the program and run it to see this exception. You can see the very first 5 values printed there, but the very last iteration, because of the I less than or equals to 5, that will be true even the 5 is not less than or equal to 5. We're going to be inside of the body of the loop and try to print array at position 5. That is why we result in array index out of bounds. Index 5 is out of the bounds of the line 5. It even tells you which line of the code here, line number 10, is the one that generates this problem. Be careful with exemption that you might get when you don't respect the boundaries of the entire array. That is why it's always important to always have not only here a.length in case something changes, but also to not go into that specific index. Let's clear off our screen, compile and run, and you will see how this got fixed, exactly as our previous example.